Today we will be talking about weathering and erosion, but more specifically, weathering due to ice.
So Beatrix, can you tell me what's the difference between weathering and erosion?
Well, weathering is the wearing down of the Earth's surface, and erosion is the wearing and transportation of the weathered material.
Wow, thanks Beatrix. Weathering and erosion happens all the time. Sand on beaches is created when wind erodes rock into fine sediments. Rocks are often broken when water gets into small cracks in the rock and freezes and expands it, therefore widening the crack and eventually splitting it. To show how much water expands when it freezes, take a look at this container of water.
It has been filled to the brim with water. When we put it to the freezer for 3 hours, the water expanded and turned into ice. Wow, look at all that ice. Some of the water must have fallen onto the plate because the container couldn't hold it all.
So, let's talk more about weathering due to ice.
To explain more about it, we are going to conduct an experiment to display the process.
We're going to find out which type of rock falls apart the most after it's been frozen several times. To do this experiment, we will be using ice as an agent to break the rock.
For this experiment, you will need a plastic container,
Water.
and many various types of rock.
This is an igneous rock called granite. Igneous rocks are formed from the cooling of magma and lava. This is a sedimentary rock called sandstone. It is formed by the compaction of sediments. This is a metamorphic rock called gneiss. Metamorphic rocks are formed by the alteration of other rocks due to much heat and pressure. This is a type of sedimentary rock called limestone. This is an igneous rock I found 2 years ago while hiking near a volcano in Costa Rica. We also included chalk as part of our rocks, even though it's technically not a typical rock. It was formed by the compaction of sediments too. It'll provide as an example to show just how powerful the ice is in comparison to the rocks. To help us understand all these different types of rocks better, geology expert Jessica is going to explain the rock cycle for us.
The rock cycle begins in the Earth's core. Earth's internal heat heats up the rock in the core, which creates magma, which we also call intrusive igneous rock. It is called intrusive igneous rock because it is found underground. When this liquid rock is erupted or uplifted due to mountain building, it becomes extrusive igneous rock because it is above ground. Due to solar energy and the atmosphere and the hydrosphere, weathering and erosion take place. This causes lithification, turning sediments of igneous rock into sedimentary rock. When tremendous amounts of heat and pressure in the mantle is applied, this rock turns into metamorphic rock.
Thanks, Jessica. Now, let's discuss our predictions for the results of the experiment.
I think this metamorphic rock will have the hardest time to break down because it has been through a lot of heat and pressure, which causes it to be more compacted, which will make it a lot harder for the water to break down.
I think that this igneous rock will be broken down very quickly due to the fact that it has so many small crevices and holes that it'll make it very easily for water to seep in and expand as it freezes and make it crumble. Also, this igneous rock is very young, so it wouldn't be as compacted and strong as it would have if it had more time to age.
I think that this sedimentary rock will break the easiest because it's very thin, so the water can get into it very easily and expand and crack it. And there are also many crevices that can be easily broken down even further.
VIP. Let's kick it.
Yeah, I think
Ice, ice, baby. Ice, ice, baby.
Here is the results of the rocks after the first time we froze them. You can see that the chalk is completely crushed due to the intense power of the ice. However, not much of the rock has broken off at this point other than a few small crumbs from the small igneous rock.
You can see how powerful the ice can be on the chalk, but the rocks were very strong. However, if you look closely, you can see some black sediment from the small igneous rock that has crumbled.
We then repeated the process by filling the container back up with water and putting the rocks in the freezer again for a full 27 hours. Once the ice is finally melted, there's really no difference between the results from the first time we froze it to the second time we froze it. For the last time that we freeze the rocks, we decide to freeze them in separate containers rather than all in one to see if it may cause the outcome to change. Like the other times, we fill up each container with water. Then we place them in the freezer. After taking the rocks out, we let them thaw for a while. Here's the results.
We predicted that the small black igneous rock and the small sedimentary rock would break the most. We were correct. The small black igneous rock had a few pieces that crumbled off, just as we thought. It had many little holes in it that made it easy for the water to seep in, expand, and crack it. The same thing happened to the sedimentary rock. It had many little crevices which made it easy for the water to seep in, expand, and crack it also. The other rocks cracked also, but not as much as these two. Or try this experiment.
Here's another sedimentary rock. If you look closely, there's already a small crack on the side. We filled the crack with water from a syringe and left it in the freezer for an hour.
Did you know?
If we filled this glass bottle with water and stuck it in the freezer, the water would freeze and expand as it becomes ice. However, due to the fact that it's sealed, there would be no room for the water to expand. So basically, it would cause the buildup of pressure on the walls of this container, and eventually the glass would break and fracture.
Wow, honestly so cool. Who knew that things like wind, ice, and water affect the world around us, especially ice?
Yep, in Canada, ice definitely shapes the land that we live on.
Rocks would be broken down outside the same way they were being broken down in the experiment we are conducting.
That's right. In the wintertime, snow falls, and as it melts, it goes into the little cracks inside rocks like pavement and concrete. This water then expands because of the cold temperatures and forces the rock apart, making it crack and crumble.